Hello guys, in this video we are going to see about calculating Van 't Hoff factor for dissociation of solute as well as association of solute. So let us start with dissociation of solute. Dissociation of solute. So in this, let us take a general reaction. For example, first let us take an example and then let us write it down in a more general form. So here example of this is nothing but NaCl. So if you take NaCl, this NaCl in an solvent, it will get dissociated into Na plus and Cl minus. So this is a dissociation reaction. Let us now write a more general equation for this dissociation reaction. Let us say A is there and it gets dissociated into some products that we can call it as B, and the number of that products we can call it as N. So now let us write the general chemical equilibrium components for this. So let's say at time t is equal to 0, we are having 1 mole of concentration of this component A and we don't have any concentration of the product. Let us say at time t is equal to capital T, we are having 1 minus alpha moles of component A. Y means alpha is nothing but the degree of dissociation, and this much amount of uh, A we will have after we have reached equilibrium, and here we will have the amount of concentration of the B as N into alpha. So I hope you can understand this. This is directly from chemical equilibrium. So how are we going to find out the Van 't Hoff factor using this? So we know that one of the form of the Van 't Hoff factor is nothing but it is equal to the number of particles after dissociation or association. In our case this is dissociation only, so divided by the initial number of particles present, initial particles. So here we can see the particles, we can refer to the number of particles at the mole itself. So let us calculate the number of particles after and before. So here as you can see, after we have reached equilibrium, this is the total number of particles that we are having. So let us add them now. So we are having 1 plus 1 minus alpha plus n alpha divided by, initially we are having just this, we are having only 1 mole, so below we can write it as 1. So now we can further write it as I is equal to 1. We can take the alpha common, so if we take the alpha common we can write it as plus alpha into n minus 1. So this is the formula for calculating the Van 't Hoff factor for dissociation of solute. So I hope you understood this. You can check it once again if you want. So now let us move to the association of solute molecules. Association of solute. So first let us take an example, and after that let us generalize it to a general reaction, chemical reaction. So the example for association of solute is nothing but when you take acetic acid, that is CH3COOH in benzene. If you are taking the solvent as benzene, solvent is nothing but benzene. What it does, it forms a dimer. So we will take 2 moles of CH3COOH. It will form a dimer, and we can represent a dimer something like this. So dimer means like this, something like this it will form. So this single A is the nothing but CH3COOH. So when you take acetic acid, 2 moles of acetic acid, the solvent is benzene, then it will form this dimer. So initially we are taking 2 moles of something, but finally we are getting only 1 mole. So this is an example for association of solute. The solute particles are getting associated less number of particles than previously it was present. So now let us write it in a general form as we did before for the previous dissociation of solute. We can write this as n amount of some substance A is getting associated into An. So this is the way we can write association for in a general reaction. So now let us calculate the chemical equilibrium things for this. So let us write at T is equal to 0. We are having 1 mole of concentration of this component A and no moles of product. At T is equal to some time capital T. There is some dissociation, that is we are using the same term called alpha, that is called as degree of dissociation here. All is covered in chemical equilibrium. So we will get 1 minus alpha, and here we will get as 1 by n into alpha. So how did we get this? You can think it of like this. You can rewrite this reaction as, you can divide the whole reaction by n, and you can rewrite it as A gives 1 by n of an. So in this case, similar to previous thing, we are having 1 nothing 1 minus alpha 1 by n alpha. So this is the way you can remember it. So now let me erase that. So this is the final chemical equilibrium parameters for this reaction. Now let us find the Van 't Hoff factor just like that we did before. So we can write I is equal to the number of particles, that is after the equilibrium is reached, which is this. So we can write it as 1 minus alpha plus alpha by n divided by the initial amount of particles, which is nothing but 1. So now we can write it as I is equal to 1. Same as before, we can take alpha as constant and we can write it as 1 by n minus 1. This is the formula for calculating I value for association of solid molecules. I hope you understood it. Thank you for watching. See you next time soon.